as we often see that enterprises are over-provisioning cloud resources just to avoid poor Java application performance and meet SLAs, which is driving cloud costs through the roof. But what if thousands of JVMs could share performance optimizations to cut those costs by 20% without any code changes? And that's exactly what Azul's new Optimizer Hub does. In today's episode of Java Reloaded, I'm here with John Ceccarelli, VP of Product Management at Azul, to discuss how it works and how it's transforming enterprise Java deployment. John, it's great to have you on the show.
Great to be here. Thanks for having me.
John, before we dive into what Optimizer Hub is, let's set the stage for our audience. What is the core problem enterprises face today when they are running large fleets of Java virtual machines in the cloud?
So we've all migrated to the cloud, or a lot of us have begun our cloud journey, and we've been promised the benefits of cloud native. And one of the major benefits of cloud native is that we could take advantage of this elastic capacity, and that we could use resources when we need them, turn them off when we don't, and only pay for what we use, that we'd be able to bring up new capacity to deal with unplanned spikes and so forth. And for that, we would pay a premium of what we would be paying for compute resources over what we would pay if we just had them in our crufty old data centers. And the major problem with Java and running these cloud workloads on Java is that the behavior at the beginning of a Java server's life is, shall we say, problematic. Yeah, that there is a period, the Java warm-up period at the beginning of the Java server's life is usually marked by a long initialization time, but then is marked by very suboptimal performance for the first, X number of transactions that server has to take. And it's very hard to work around that problem. And when we had always on servers, that was fine. But then when we moved to this world where we're running on Kubernetes, we're running in the cloud, when a server can get shut down at any time because Kubernetes decided to rebalance nodes and to move it to another node, or when you're using something like Lambdas, where literally at the end of every REST call, you're shutting down the JVM and then starting it again, this problem comes to the fore. And it's keeping people from really getting all the promised value out of the cloud because people are just leaving resources provisioned always on for max capacity, leaving lots of wasted capacity, lots of wasted spend, lots of wasted CO2 and emissions, right? If you're tracking towards your sustainability goals, right? So not being able to capture the full value of cloud native. And so that was the problem really that we looked at, but we're not the only ones. GraalVM was very much focused around that problem, and lots of people looking at this problem, but we feel really good about the way that we have solved this problem, yes.
And now it's time to break down the Optimizer Hub. You are enabling 10,000 plus JVMs to collaborate and share optimizations. What's actually happening under the hood here, and how does this change the performance profile for cloud native Java applications?
So this is real cutting edge stuff. And so there's two parts here, really. There's a JVM, and then there's this set of services that is external to the JVM. The JVM is Azul Platform Prime. And this is our high performance build of OpenJDK. We start with OpenJDK, and then we replace a few components with more optimized components. And then on top of that, we layer in some things which aren't really available elsewhere. So that's the JVM that these customers that we referenced are running in their data centers. And what they're doing is they're talking to Optimizer Hub. And so Optimizer Hub is really two things. So the reason you have the suboptimal performance when you start is because the JVMs need to spend a lot of their local CPU crunching a bunch of code in order to take that write once, run anywhere code that Java delivers and make it really fast, optimized for that particular server that you're running on, and specifically for the workload that you're running and how you're running it, right? And in traditional Java, this is something that could only happen once you started running the code. The Java needs to actually run the code a couple of times, more than a couple of times, lots of times, in order to figure out how to optimize it so it can bring it to full speed. So that means unless you're doing a bunch of tricks to fake some transactions before you take traffic, it is when you're taking traffic, that's when you're running code in very slow mode. It's spending a bunch of CPU resources on the JVM to try and optimize it, right? And at the same time, your users are suffering from bad user experience. So what Optimizer Hub does is it just takes that whole process off of the server and puts it on this external service that sits outside of it. So now the JVM wakes up and it says, I'm running this app. And it asks Optimizer Hub, hey, I'm running this app. Help me out here. Yeah. And Optimizer Hub not only can perform all that work over here so that your server is 100% focused on delivering your traffic, but Optimizer Hub also has intelligence in it that it monitors what you're running and how you're running it. So it knows even before you ask, it knows exactly what optimizations you need. And it has a cache because the last time it ran all those optimizations, it saved it in a cache, so it can send it immediately. So what you get is faster time to full speed. You get lower and smoother CPU, right? And now I can auto scale with confidence. I can now use that auto scaling, use that cloud elasticity with confidence because I don't have to worry about my users being affected when they land on a newly started server. So that's what we're doing. And the 10,000 plus, I mean, a lot of people, they talk to them and they're like, wow, this sounds cool, but this sounds like a science experiment. This is crazy. Is anybody actually doing this? And what we wanted to tell the world was, yes, we have large customers who are running their entire estates on this. And you have one Optimizer Hub instance that can handle 10,000 JVMs plus going against it, right? So we just wanted to tell the world, this is real. This is here right now. And it's available on all code from Java 8 to today. No code changes, no recompilation, nothing. Just switch the JVM, hook it up to Optimizer Hub, and off you go.
Excellent. Thank you. You focus a lot on efficiency, performance. Let's just quickly talk about cost, because when I was going through it, it's almost 20% cloud cost reduction, and organizations are becoming very, very cost sensitive in this economy. Infrastructure spend is under the microscope at almost every organization. Just walk me through, you did touch upon a lot of factors, but just walk me through the mechanics of how when we put Platform Prime with Optimizer Hub, it delivers those savings without, as you rightly mentioned, any code changes.
What we're doing is we're basically getting the most we possibly can out of a single server, so you have to have less servers overall. And there's three ways that we deliver that. So the first way we deliver that is that through our pauseless garbage collectors and through our other technology, we've basically removed 95% of the stalls, freezes, and jitters, the latency outliers that people used to have to reserve capacity that would stay idle most of the time, but in, 0.001% of the calls would actually show up, right? So now that this JVM can meet your SLAs, can give good performance even when you press it harder, we can now start raising our utilization of these JVMs. Instead of only using 35% of the CPU, now we can use 50%, 60% before we start scaling out other machines. That means more transactions through one server, right? And less servers overall. So similarly, our compiler, our JIT compiler that does this optimization, not only does it have this facility to offload all that to Optimizer Hub, but it also is the world's fastest JIT compiler. And it produces code that runs 40% faster, 40 to 50% faster than OpenJDK. So now with each transaction taking less CPU, that means again, I can now run more transactions through one server. I need less servers overall. And then finally, the best way to save money on a server is to turn it off, right? So if you weren't able to, if you were provisioning for always on before, now with the Optimizer Hub technology, I can start actually scaling based on my load, doing that more aggressively with more confidence. Those three things put together add up to on average, a 20% savings for our customers on their cloud cost bill, while at the same time, you're improving the customer experience because you're getting better performance, lower latencies, and less pauses and jitters and freezes, associated with just regular running or with starting up new JVMs.
You touched on this earlier, but as we all know that JVM warm up and performance unpredictability have been plaguing enterprises. I mean, Java has been used for years, but it has its own reputation as well. We all know that. How does Ready Now and Cloud Native Compiler address this in modern environments where you are, I mean, CI/CD, you're constantly, scaling containers and managing elastic workloads. So you have to be nimble there.
The compilation, the JIT compilation or the optimization process by which you go from this very slow code that can run on any machine to very fast code that's running on this specific machine. This comes from the 90s. Yeah, this is from back before we had a cloud, back before we had like multiple servers and so forth, right? And really, like I said, it needs to actually run the code each time to figure out what needs to be optimized. It's like if you remember that movie Memento, where the guy didn't have any kind of memory, and every 5 minutes he had to look around and go, "Oh, what am I doing?" Java's like that. Right? It's like it wakes up and it goes, "What am I doing? Oh, I'm running this thing, Kafka. Never heard of it. I guess I'll have to figure out how to optimize it." But you've run Kafka 1,000 times. You probably have 100 other JVMs right now that are running that code. Why can't these JVMs just share? Why can't you just have a central place that knows exactly how you run Kafka, knows exactly what optimizations you need for Kafka, and can serve those up immediately because it already has those optimizations because somebody did it beforehand? That's how we're tackling that Java warm-up problem, and it's very, very successful. And again, unlike a lot of other solutions, only work on certain JDKs, or they don't support the entire Java spec, so you have to try and rewrite your code in order to get working with them. This is from JDK onwards, no code changes, just plug it in and it goes.
I love the analogy of the movie that you gave. That was excellent. Thank you. Now, the fact is, a lot of enterprises, they are already standardized on OpenJDK or other Java runtimes. What kind of challenges or seamless adoption path is there for them to move to Azure Platform Prime? How do you handle migration at that scale, especially in production environment, without adding more headaches to the teams?
So one thing that you hear is I've got 500 apps. I can't run a tuning exercise on each app. I don't run a migration pattern on each app. I can't do this, right? So what we do is we come in, we've got the world's foremost Java experts on Java performance here. And what we do is we come in and what we do is we build one optimization profile that is going to work over your entire estate, right? And so Java performance is infamously tricky, right? Some things are I/O bound, and you can speed up the JVM as much as you want, but the bottleneck's in the network layer, so you're not going to actually get better performance on it. So our goal is to give a performance that on average is going to deliver that 20% across all of your applications. So you don't have to do a different tuning exercise for each one. Like I said, there are no code changes. There is no recompilation. It's just a matter of finding those different JVM tunings, right? And putting them in. And actually, one of the things that in the past we used to tune the most, the thing that would cause us the most problem was this JIT performance, right? Because getting those faster compilations, right, was difficult to do that on some of these smaller machines that didn't have as much CPU to do that performance. And what we found is by just putting in this exporting that all out to an external service, that the service takes care of all of that. And now it's really a cinch to get these apps migrated over, because we're not having to try and balance all those CPU resources and so forth between doing the optimization and running your code. We just shoot it all off to OpTub. OpTub does it, returns the optimized code, and off to the races.
Now, depending on industry, there may be a lot of organizations who are in heavily regulated industries, or these days, of course, security, privacy, compliance is becoming a big issue. When we talk about sharing performance data across JVM, it might raise security or isolation concerns for enterprise architect. How does Optimizer Hub also maintains security boundaries while enabling this collaborative optimization?
Right. Well, so the first thing that's important is that OptHub is not a SaaS product. We are not asking you to send your code with customer data and so forth into it over to our servers so that we can then send you code that you're going to execute inside of your environment. This is a Kubernetes cluster that you set up in your environment that you maintain. Typically, what we find is customers set up one of these per geo in their cloud and really route everything to it. And then we have high availability between geos, or you can set up two for high availability within one. We have yet to find a customer that within their DMZ was concerned about the type of information that was going back and forth and having that in a central repository. But those who are free to set up, one per group, whatever that cordon you need as far as security goes there. But remember, what we're talking about getting sent to the server and back is really just method names and so forth. The only thing that could possibly have any kind of information in it that would be personally identifiable information would be maybe some constants, right? Potentially there could be some like constant data that would be needed for the context in order to compile those things. So in general, there's a very, very low possibility of anything actually being transmitted in there that you wouldn't want going outside of that one group. But yeah, we're definitely, none of that is crossing the firewall outside of your estate.
What's the typical ROI timeline enterprises are seeing when they deploy Platform Prime with Optimizer Hub? Are we talking about years, weeks, months, quarters, days, or hours?
Typically, we'll go in and, a migration project will take like a couple of weeks basically for us to, and this is not like a couple of weeks where the team is going to only be working on that. This is a couple of weeks where we kind of iterate, you got to get your test environment set up and so forth. So we get that through, but then the ROI is immediate afterwards because, and the ROI really is the more you deploy to it, the more you save. Right. But, if you look at it, when you're talking about a paid product, paying for something that was free before, right? How does that make sense? And we like to say that we are more cost effective than free, because at the end of the day, the gains that the savings you're going to get from compute costs that we're going to save you, not to mention developer costs from, save developer time, that your developers don't have to be worrying with performance issues because you've pushed those performance issues down to the platform to solve and so forth, right? Those savings are going to completely outstrip whatever you're paying Azul in licensing. So yeah, even we love going up against free because we kick free's butt when it comes to cost savings for the customer.
So you are sharing optimization across thousands of JVMs. What happens when you have got mixed workloads or different application patterns? Does the system get smarter over time, or are there scenarios where this collaborative approach doesn't work as well?
No, any workload can benefit from this. So any Java workload can definitely benefit from this. And each app is encapsulated. So each app, the Optimizer Hub is going to, if you send me a request for java.lang.string, right, and it has its context, which means, java.lang.string, not a great analogy, but, you send me a request for a method, right, and it has its context for how it should be optimized so it runs fastest for this app. And then a second app sends you a request for that same Java method, right, but it has a different context. we know which app we're responding to in each case. And our cache has both of those things cached. So it knows that app foo over here gets this version, app bar over here gets that version, and both of them are getting the absolutely fastest version possible for that specific way that those two apps are using that same method.
Now I want to talk about the stress that teams may go through for platform engineering teams managing hundreds or thousands of Java services. What is the operational overhead looks like? Are you adding more complexity to their day-to-day management, or you are easing it and simplifying it for them?
Right, right. So, I mean, obviously, Optimizer Hub is a service, and what you have to pay for in that privacy and keeping everything inside your data center is that you have to actually provision it. But it's a Kubernetes cluster. It's a Helm chart. There's nothing really very exotic with what's happening inside of it. It does scale rather aggressively. So we have an operator-based scaler that can handle that scaling at very aggressive forms, because when a new wave of optimization does come up, we need to bring a lot of JVMs online in order to serve that. But other than that, that's it. And if you look on the other hand on the gains, right? When you look at what's more difficult, figuring out how to run fake transactions through a JVM so that you can warm up the code before you start taking actual user traffic, and then figuring out how to make sure that those fake transactions don't get mixed up with real transactions and mess up your data, right? What's more difficult? Having to wait to do your CI/CD redeploy till 3 a.m. on a Saturday morning because you're afraid to redeploy your fleet in the middle of a business day, or being able to actually do multiple CI/CD redeploys through the whole life of your business day, right? And then you think about just reliability. Bad stuff happens in the cloud, right? Nodes go down all the time. Entire data centers go down. Bad stuff happens. Right. And so when you're trying to come back from either a single node failure or a catastrophic event, right, you want those things getting up to speed as quickly as possible. And that's what Azul Platform Prime and Optimizer Hub is going to give you. So yeah, there's some cost, just like any service, you have to set it up, you have to run it. But the benefits to your operations team and how smoothly your Java deployments are going to run is really tangible.
We are seeing a lot of focus on FinOps and cloud cost optimization these days. How does Optimizer Hub integrate with existing cloud monitoring and optimization tool that enterprises already have in place?
Yeah, we're very into FinOps. I'm a FinOps certified practitioner myself, and so there's the FinOps world has been really focused on observability. They've been focused on how do we observe costs, how do we track costs, how do we back charge costs to individual departments? How do we recognize anomalies? And then it's been looking at okay, what are our cost savings opportunities when you get to the optimize phase of the FinOps framework, right? What are our cost saving opportunities? But most of what teams that are doing FinOps are doing, there's this low-hanging fruit, which is super valuable, which is hey, let's turn these things off. Let's run these things on spot instances. Let's put this data over here in this other tier, right? Those things are super valuable. And if you haven't done anything at all, they can save you a ton of money. They're absolutely the first things you can do. But then you hit a wall, right? What do you do next? And what do you do next comes down to one of two things, right? First, you can re-architect, right? But a lot of people who have been driven to the cloud have been driven by these, data center closure, goals of we must close this data center by X date. And what they've done is they've just lifted and shifted old monolith 3-tier applications over onto the cloud, right? They didn't have time to re-architect those things. They still don't have time to re-architect those things. Those things are running on the cloud where compute costs more than their local data centers, right? And they're burning through money, right? So these people, they need a way to get some relief, some cost relief on these applications without having to go and refactor them for cloud native, right? So we offer people who have brought their legacy 3-tier monolith apps onto the cloud, a way to recoup some of that additional cloud costs that they incurred by moving from on-prem to cloud. And then when you do re-architect, you hit another wall where you get to a point where you're like, okay, I'm already cloud native, I'm auto scaling. How am I going to get some additional savings, right? And they don't have in the code they've run out of things they can really do in the code easily that they can do in the code in order to deliver additional savings. And these people all have huge backlogs of features they actually have to deliver, right? They've got huge time to market pressure on delivering the value. And so that's another place where, hey, even if you've done everything right and you think this is as fast as it's going to get, or hey, these GC pauses, these latency outliers are just a fact of life, and we have to live with them. Then you come in and you just swap out the JVM, and you're like, oh my God, there's another 20% code speed. There's another complete reduction, complete elimination of my P99 outliers, P99.99 outliers. So we are complementary, but probably the biggest challenge we face is people never think of the JVM as a FinOps tool. People never think of the JVM as a cloud cost optimization tool. And we're trying to yell it from the mountains that yes, you switch out the JVM, you can reduce that cloud cost significantly without having to do the rehost, the refactoring, re-architecting, and so forth that you would typically have to do in order to get those savings.
In the beginning, you talk about other players may be doing the same thing. What is the competitive landscape looks like right now? How do you position this against other JVM vendors or cloud-native solutions that promise similar performance gains?
Well, we just had a very significant announcement about one of our biggest competitors just last week, which was GraalVM, which GraalVM was another tool that played in this space, was used mostly, I think, for Lambda services and so forth. And the Java team announcing that it was going to discontinue its involvement in GraalVM. And it's putting GraalVM out as part of the Java SE subscription and developing GraalVM features as part of OpenJDK. So that was a big shift in the competitive landscape there. There are a lot of folks who are doing well. I mean, the biggest competitor is do nothing, right? That's the biggest competitor, and that unfortunately is the most common thing that we see. The other way people derive cloud cost savings are, of course, re-architecting to cloud native so that they can take advantage of cloud elasticity and scale things in different ways. But again, you have to have the people to do that. You have to have the time to do that. That has to rise up to the top of and very few people will do complete re-architecting just to get cloud. That's a very tall ask for a lot of engineering teams to just do that, just to reduce your cloud costs. What we're seeing, and this is a very complementary approach, is a lot of the Kubernetes autoscaler, the Kubernetes sizing engines. So there are a lot of folks out there who are putting out some machine learning AI-driven systems that will monitor your Kubernetes fleet and look for inefficiencies and be able to automatically resize vertically your nodes and that's a really good complementary approach to one of these systems optimizing your Kubernetes while we optimize the app that's running inside of Kubernetes. So there's a lot of goodness to happen there. And then also we see OpenJDK is not Java. The Java language itself is not standing still. So we're seeing with Java 25, Project Layton came out. The Project Layton engineers are very upfront about the fact that they base much of their approach on the Ready Now technology that Azul Platform Prime has had in production for 8 years now. And so they've got some experimental stuff coming. We are very excited. We are engaged with them. We think it's going to be very exciting to see how we can collaborate on making some of these problems be solved inside of the Java language itself, the JVM itself. And so yeah, I think there's a lot of exciting stuff happening in the community around this.
John, this has been really insightful. Thanks for walking us through how Optimizer Hub is tackling these Java performance and cost challenges. Thanks for your time today, and I look forward to the next conversation. Thank you.
Thank you. Absolutely a pleasure to come, and we're happy to come anytime.
And back to our audience, thanks for watching, and don't forget to like and subscribe, and we'll see you in the next video. Thanks for watching.